Good morning, all of you. My name is Meghana. I am from Triple E. Today, my topic is determination of a self-inductance of a toroid, presented by S. Meghana, class BTech third sem, and I am studying in Institute of Aeronautical Engineering College, Tundigal, Hyderabad. Introduction to self-inductance. Self-inductance is the property of a coil that opposes changes in a current flowing through it. It is a fundamental concept in electromagnetism, crucially for understanding inductors. The self-inductance of a toroidal coil is influenced by its geometric and material properties. Self-inductance. Uh, Self-inductance. Consider a solenoid L connected into a battery. Area L length L n is a turns. What happens as you close the switch? Lenz's law. Loop resists change in a magnetic field. Magnetic field is caused by the current. Inductor resists the change in the current. B equal to mu naught Ni by L. The formula of self-inductance is E equal to minus L di by dt. L equal to mu naught n square A by L. This is the equation of a self-inductant. What is a toroid? A toroid is a donut-shaped magnetic core, typically made of a ferromagnetic material. The design of a toroid helps in a configuration magnetic fields, minimize external interference. Toroidal inductors are widely used in power supplies and RF applications due to their efficiency. Magnetic field in a toroid core. Formula for self-inductance. The self-inductance L of a toroid can be calculated using this formula. L equal fraction of n square mu naught A. Here n is the number of turns and mu is the permeability of the core material. A is the cross-sectional area and I is the mean circumference. Understanding this formula is essential for calculating the inductance accurately. Inductance, self-inductance. Consider solenoid and we know the value of L. L equal to mu naught n square A by L. It is a self-inductance formula. Factors affecting self-inductance. The self-inductance of a toroidal coil is affected by the core, by the number of turns in the coil. The core material is permeability plays a significant role in the enhancing the inductance. Self-inductance. This is the circuit diagram of the self-inductance. We know the primary current, what is in it is a coil, and induced current, induced EMF. There is a magnetic field due to the primary current, and this circuit we supply the power of AC current. Measuring self-inductance. Self-inductance can be measured using a LCR meter, which provides accurate inductance values, and alternative methods involve using an oscilloscope and function generator to analyze the response of the coil. Calibration of the measuring instruments is crucial for obtaining reliable results. Experimental step up. The experimental step up required a toroid coil, an LCR meter, and connecting leads properly configuration. The toroid within the measuring circuits ensures accurate inductance reading. Environment factors such as temperature can impact the measurements, so they usually be controlled. Calculating cross-sectional area. The cross-sectional area A of a toroid is calculated by using formula A equal to pi r square by r, where r is the radius. Knowing The cross section is a visual for the determining the inductance accurately. Variation in the cross sectional area can lead to significant changes in the self inductance values. This is the calculating process of a sectional area, and way, uh, there is a formula, and there is a question to calculation of the cross sectional area. Water flows smoothly through a pipe at a speed of 1.66 meters. The water then flows smoothly from the first pipe to a second pipe at a speed of 1.22 m meter square. What is the ratio of the cross sectional area of the first pipe to that of a second pipe? So we have to find there the ratio of the cross sectional area of the first pipe to that the second pipe. There is a two pipes are there, and we have calculated, we apply the formula of a1 by a2. There is a v1 equal to 1.66 meter square, and we have where we to give v2 equal to 1.22 meter square. So here epsilon naught av is called constants. So a1 by a2 equal to a1 by a2 v1 by v2. So we have know what is the value of v1. So there is a v value is 1.66 meter. So we have done with a equal to 1.22 meter by 1.66 meter. So a1 by a2 equal to 0.735. This is the value of calculating crossing sectional area. Importance of the core material. The choice of a core material significantly affects the inductance and efficiency of a toroid coil. Materials with the high magnetic permeability enhance the inductance, leading to better performance. Common core materials including ferrite and laminating iron, each with distinct properties. Calculating mean circumference. The meaning circumference I of a toroidal is determined by the formula 1 equal to 2 pi r, where r is the mean of radius. Accurate calculation of the mean circumference is essential for using the inductance formula. Variations in the mean radius directly impact the self inductance value. Effects of number of terms. There is a circumference of a circle we have seen in this figure. Uh, mm, the point, the middle point to radius is called diameter, and this is radius. Total circle is called circumference. Effects of number of turns. Increase the number of turns n in a toroidal coil, increasing its self inductance proportionally. More turns generated a stronger magnetic field, enhancing the over-inductance proportionally. More turns generated a stronger magnetic enhancing the over-inductance. This relationship highlights the importance of the design choice in a toroidal coil applications. Applications of toroidal inductance. Toroidal inductors are commonly used in power supplies due to their compact design and efficiency. They are also utilized in audio equipment and the radio signals supplies due to their compact design and efficiency. And they are also utilized in audio equipment where low electromagnetic interference in a circular of a toroidal inductors make them suitable of various electronic applications. Challenges in a measuring self-inductance. External magnetic fields can with interfere with the measurements of inductance. Accurate positions of the toroid with the measurement circuits are critical for reliable measurement. Environment conditions such that environment conditions such as a temperature and humidity can also affect the measurements. Conclusion of this topic is understanding the determination of self inductance is a toroidal coils is essential for the designing efficient circuits. Accurate measurement techniques and knowledge of influencing factors improve inductance calculations. The applications of toroidal inductance continue to expand in a modern electronics, emphasizing their revaluations. Thank you.